Okay, I'm Carol Stone, co-chair of the committee, and my co-chair Jeanette is right here with me there. And we are very pleased to hear this Earth Day month speaker. Gary Griggs is a distinguished professor of Earth and Planetary Sciences at the University of California, Santa Cruz, where he has taught for 55 years. He received his BA in Geological Sciences in 1965 from the University of California, Santa Barbara, and a PhD in Oceanography from Oregon State University in 1968. Gary served as the director of the university's Institute of Marine Sciences for 26 years, where he led the development of a coastal science campus. His research, teaching, writing, and lectures have been focused on the coast of California and include coastal processes, hazards, and the impacts of and responses to sea level rise. In 1998, he was given the Outstanding Physical and Biological Sciences Faculty Award at UC Santa Cruz, and the Alumni Association honored him with a Distinguished Teaching Award in 2006. The California Coastal Commission and Sunset Magazine named him one of California's coastal heroes in 2009. And in 2010, he was elected to the California Academy of Sciences. Gary chaired a committee in 2017 recommended by Governor Brown to update California's sea level rise projections. In 2016, he was appointed to the California Ocean Science Trust. Gary is also a member of the California Ocean Protection Council's Science Advisory Team and served as chair of California's 4th Climate Assessment Committee on Coasts and Ocean. In addition to all of this, Gary has written 13 books, including Living with the Changing California Coast, Introduction to California's Beaches and Coast, The California Coast from the Air, Coasts in Crisis, a Global Challenge, The Edge, the Pressured Past and Precarious Future of California's Coast, Between Paradise and Peril, the Natural Disaster History of the Monterey Bay region, and most recently, The Ominous Ocean, Rogue Waves, Rip Currents, and Other Dangers Along the Shoreline and at Sea. So that is our introduction to Gary Griggs and a topic that we are really interested in.
Okay, thank you, Carol. With that introduction, I don't feel like I have to say anything. You just said it all. So this title is what I'm going to talk about. It's pretty clear. So trying to combine climate change, how that affects sea level, and then how that affects the California coast. And this first picture sort of epitomizes some of the worst of that in Pacifica. Those apartment units are no longer there. Let's see here.
Pacifica, okay.
So there's sort of two ranges of things to think about when it gets to the shoreline. One is long-term sea level rise we'll talk about, and the other are short-term, what I'll call extreme events. These extremely high tides, storm waves arriving at times of high tides, which we had in early 2023. And this is the Embarcadero, I'm sure a place you know, at a high tide, which shows you really how close sea level is to many developed areas. I don't feel I even need to say anything about this picture. It's Miami, and you probably all dealt with these parking kiosks. And I kind of wonder what this guy's doing. The only thing I can think of, he's ready to bring his boat in. He's going to have to get a parking permit for his boat. But it's so Miami. So a little bit of history. In 1965, I started graduate school in oceanography at Oregon State and spent a couple of years out in the North Pacific. And what we were doing was basically looking at the sediment record on this deep sea floor. We were about a couple hundred miles off the Oregon coast, and we were taking cores. This is
Recording in progress.
taking sediment cores where we drop basically it's a 2,000 pound weight with a long piece of pipe into the seafloor, and then we bring back sediment cores. And the ocean is this great repository of history. And what I found, the beginnings of my involvement with climate change, the surface sediments, when the water's been fairly warm, say the last 10 or 12,000 years, when we sifted out all the silt and the sand and the clay, we ended up with a dominance of these radiolaria, which are microscopic. They're made out of silica. They are animals. And as soon as we got back into the cooler water during an ice age, we washed out all the mineral grains. We ended up with this dominance of cold water foraminifera. So that was my first foray into sort of paleoclimate work. And now, from a number of different lines of evidence, one of these is actually drilling into the ocean floor, which we've done now for over 50 years. We've gone back about 65 million years. And as the climate changes, ocean conditions change, warmer, cooler circulation, the organisms that live in the surface ocean, that live and die, are deposited on the seafloor. And we can use various geochemical indicators to find out whether it was warm or cool. We can go, and we've been going into the ice of Antarctica and Greenland, and we've now drilled back about a little over 2 miles into the ice. And this is not a picnic down there. It is very cold and very hard to work, but we've gone back about 850,000 years. And I'll see a little bit more about that. In California, down in sort of southeast California, we have these bristlecone pines that live to be about 5,000 years old, and a number of types of trees, these are one of them, record in their annual growth rings temperature, climate. And then relatively recently, we've discovered in the deep water off California, there are deep water coral. These don't form coral reefs. These are in water of 10 or 12,000 feet, but their stalks, if we cut into them, actually record annual changes in the water above them. And these can go back to 2,000 to 5,000 years. So a lot of different evidence of climate change. Climate has changed throughout the entire period of the Earth's history, and the major determinant in that until recently has been basically the distance to the sun. That produces the solar energy, the radiance that drives a lot of Earth processes. And way back in the early part of the last century, people began to realize this and discover that, in fact, our distance to the Earth, distance to the sun changes on 3 pretty well understood cycles. One of these has a cycle of about 26,000 years. So the Earth actually has a wobble on its axis. So that can take us a little further away from the sun, a little closer. The Earth has a tilt on its axis. It's a permanent tilt, but it varies between about 22 and 24.5 degrees. So that tilts the Earth a little bit away, a little further away from the sun, a little bit closer, with a cycle of about 41,000 years. That also gives us the seasons. So in the Northern Hemisphere, when we're tipped away from the sun, it's our winter, and Southern Hemisphere is summer. And then the Earth's orbit around the sun isn't a circle, but it's an ellipse. And that has a cycle of about 100,000 years. Determining this was pretty amazing that people did it over a century ago. So these are all working together to change the amount of sunlight we get on the Earth. And why does that happen? We now believe, so the Earth is about 4.5 billion years old. We believe maybe within 100 million years of its formation, give or take a few million years, the the Earth was hit by a smaller planet, maybe the size of Mars, which has been given a name of Theia. They were both still pretty much molten. And when that impact occurred, it did a couple of things. Some of the heavier material from that planet went into the center of the Earth because it was molten and gravity pulled it to the center. Some of the outer material that was lighter sort of got splashed out so that continents today don't completely cover the surface. And that material coalesced and aggregated to form the moon. There's a long period of trying to figure out how the moon formed. And now we've been there, and it looks like we're going to go back again and looked at the chemistry and so forth. But the other thing it did was it threw the Earth off its perfect vertical axis, and it gave us this tilt and this wobble and this eccentric orbit around the sun. So drilling into the ice, and this gets into the climate piece here, we've gone back a little over 2 miles. When snow falls, it actually traps a little bit of atmosphere, a little bit of air in there. When you see snow initially fall, and obviously this year in the Sierras, we've had, record snowfalls, it traps air in there. And over time, as that snow melt or the snow builds up on top of it, it begins to compress and it crystallizes to ice. So that's what we're coring in Antarctica and Greenland. But in the ice, we can take these cores and we can actually extract these little bubbles of air. And then we can use things like mass spectrometers to analyze the composition of that ancient atmosphere. And this is a history that's going back, again, about 800 a little over 800,000 years. This is from one of the ice cores. And on the vertical axis is the amount of carbon dioxide in those little air bubbles. So you can see for the history or the length of this core, carbon dioxide varies between maybe 175 and 275 or so parts per million. Carbon dioxide isn't a big component of the atmosphere. It's mostly nitrogen and oxygen, but there is carbon dioxide, and it's a very powerful greenhouse gas. What has happened, beginning with the, the Industrial Revolution, carbon dioxide has gone up. We're burning coal and oil and natural gas that all produce carbon dioxide. It's ending up in the atmosphere. It's ending up in the ocean. So the most recent numbers, and these are collected at Mauna Loa in Hawaii because it's a pretty clean atmosphere. We're now from this at least 800,000 years of a very pretty constant range here. It's gone up by about 50% and it's rising every year. It's an interesting issue of sort of feedback mechanism, but you can see these cycles are about 100,000 years apart. And those are the reflection of how far the Earth is away from the sun, which drives some other climate changes. So it's a complicated system. About 1955 or so, the then director of Scripps Institution of Oceanography, a really brilliant man, Roger Revelle, he was sort of one of the early climate scientists, oceanographers, and he understood, as others had before him, that carbon dioxide was generated by burning fossil fuels, and it was accumulating in the atmosphere. But so many places on the continental US have contamination from autos and industries. So he sent then a young Charles Keeling to Hawaii and said, I want you to move to Hawaii and I want you to set up an observatory at the top of Mauna Loa to measure carbon dioxide, which is a pretty standard measurement. He did that for until about 2005. He passed away. He was given here the Congressional Medal of Honor, the Presidential Medal of Honor. Now his son has taken this over. It's now called the Keeling curve. But what you can see, this is the amount of carbon dioxide in parts per million beginning in 1955. What you can see is it's increasing. And not only the amount is increasing, but the rate is increasing. The slope is getting steeper. And if we look at historically during these different periods, 59 to 64, 65, the amount that it's increasing is accelerating. In fact, the most recent measurement was 2.55 parts per million. So this is what's happening from our fossil fuel consumption. If we look at the cumulative amount of carbon dioxide and attribute this, it turns out about half of all that in the atmosphere has been generated by 4 countries. The US has generated about a fourth of that. We have about 4.5% of the world's people, but we've generated about a fourth of all the carbon dioxide. China, number 2, Russia, Germany, and then you can see there's 190 other countries that have generated the rest. If we look at it now in 2021, because those records go back quite a ways, it turns out China's, not only their population is growing, but they're becoming heavily industrialized. So this is the per person emissions each year in tons of carbon dioxide. And this is the population. So if you multiply the number of people and how much they're emitting, you get a total volume. So now China is emitting more than any other country, about twice as much as the US, but you can get some idea about the size of these little rectangles. So China, US, India, Russia on down is what's happening today. Back in the late 1800s, a Swedish chemist who ended up winning the Nobel Prize, he sort of was given credit for carbon dioxide trapping heat through the greenhouse effect. There are lots of natural greenhouse gases in the atmosphere: carbon dioxide, methane, nitrous oxide. Those produce an average global temperature of about 60 degrees Fahrenheit. Without those, the average temperature would be 0. So those natural greenhouse gases hold in heat and have made the planet much more habitable. And that's physical science, not political science. So if we look back to, for some reason, around 1880 is when we started recording a lot of things like global temperature and carbon dioxide. So if you look at the record from 1880, this goes up to 2013. This is the carbon dioxide in the atmosphere, which is now up to 420. And this is the temperature. So they are parallel to one another, and they're both increasing. And this is sea level, going back to 1880 also. I'll talk more about that, but historically, we measured it by looking at water level recorders or tide gauges around the planet. The problem is with those, they're attached to something on land, a pier, a breakwater, rock, and they reflect what the water level is doing relative to land. So if the land is rising or sinking, this gives us a relative number. In 1993, we launched a series of satellites, which are now measuring it precisely from space. So that also parallels temperature and carbon dioxide. So while Arrhenius gets credit for it, interestingly, looking back into the history, it was actually discovered earlier, the greenhouse effect from carbon dioxide, by this Irish physicist, John Tyndall. And then looking back a little further, the first person who discovered that was Eunice Foote, who was an American chemist in 1856. And at that time, maybe not a surprise, it was very difficult for women to get into science, to publish papers, to give talks, but she is now given credit for basically being the person in a laboratory to figure out that carbon dioxide was a greenhouse gas. So where does all that CO2 come from? About 91% comes from burning fossil fuels and making cement. The manufacture of cement produces about 5% of all the global carbon dioxide. About 9% comes from land use changes. So, burning the rainforest, the forests we've had that have burned in California in the last couple of years all produce a lot of carbon dioxide. Where does it go? About half of it goes into the atmosphere. Roughly a fourth is taken up by vegetation. and about a fourth goes into the ocean. And what that's doing, now our going to the ocean is making the ocean more acidic. And you may have read about OA, or ocean acidification, and that's producing a number of problems for coral reefs and organisms that make shells out of calcium carbonate, which is very difficult as the oceans get more acidic. So in the next hour, I won't talk that long, but if we did talk for an hour, the world will burn over 4 million barrels of oil in an hour and 1 million tons of coal. And all those are producing carbon dioxide. I didn't pick this picture out specifically, but you make it recognize the area here is Emeryville and Berkeley. And so burning fossil fuels for power, transportation, and the important thing is we're not running out of fossil fuels yet. There's still oil out there and gas and coal, but we're running out of atmosphere. We're running out of a place to put it. You can see the Midwest, we're still mining tons of this, but exciting, this last year, the U.S. Energy Information Administration reported that in 2022, for the first time, the U.S. produced more electrical energy from renewables than coal. Coal is on the way down. It's no longer economically feasible. It's the dirtiest fuel we have. So that's a good thing. And it looks like the global economy is following that a little behind us, but still 77% of all of our energy in the US is produced by burning fossil fuels. So making that change is not going to be easy. The more heat that we retain, the warmer the planet's getting. So this is a plot going from 1880 to 2022. And if we use the period from 1900 to 1960 as sort of base, we average the temperatures through that period of time, that gives us the zero here. These are now differences or anomalies from that base period. So before that time, it was cooler. These are degrees Fahrenheit, and you can see what's happening is these are now increases over that period. So most of the warmest years that we've been recording have all been since the year 2000. This is pretty clear. This is ocean and atmospheric temperatures. This is just pure measurements. So as the Earth has warmed and cooled, sea level has risen and fallen. So when it gets warm in an interglacial period, ocean water gets warm and water expands as it gets warmer. And ice melts, adding water to the ocean. And all ice melts at 32 degrees Fahrenheit. It doesn't matter if you're a Democrat or Republican. So that's what's happening as it's getting warmer. This is now a record of sea level over the last 370,000 years from some of those cores from the seafloor. So what you can see is during a glacial period, we sequestered over the last several million years about 3% of the ocean on land as ice sheets and glaciers. That drops sea level about 400 feet repeatedly. During an interglacial period, it starts to get warmer, the ocean expands, and ice melts and flows into the ocean. So we've had these roughly 100,000 year cycles again, which is that period of the orbit around the sun. But what's interesting here is what we call sea level today is what it's been for the last century, but at any other time in Earth history, the sea level and the coastline would have been someplace else. So if we go back 120,000 years, it might have been 10 or 20 feet higher than today. And if we go back about, 120,000 years, if we go back about 20,000 years, it was 400 feet lower. And I'll show you what that looks like. And then as it warmed up, it's risen back to where it is today. So this is just blowing up the last 20,000 years. That was the last 370,000 years. This is just the last 20,000 years. So here's where we are today. We're calling it zero. This is going down 450 feet. So this is the end of the last ice age. Sea level was very low, maybe 390 feet lower than today. It was cold. Ocean water went on the land as ice sheets, glaciers, and sea level dropped because it was, we've taken that water out of the ocean. So from about 18,000 years ago to 8,000 years ago, sea level rose fairly quickly. You know, 1.5 meters, 45 inches per century, about 1/2 inch a year. But within that period, there was some intervals where it rose very rapidly, maybe almost 1 inch per year, which we can almost watch. And we think this is when the ice sheets of Antarctica collapsed, which is what we're studying today. And then about 8,000 years ago, sea level leveled off. So for the last 8,000 years, which happens to correspond to virtually the entire period of human civilization, and there's some connection there, less than 1 millimeter per year. This is the rate now, about 20 inches per 100 years or 5 millimeters per year, about the thickness of 3/4. But that rate is accelerating. And the question is, how high is it going to get? And when's it going to get there? And I'm going to make a bold statement that this may be the greatest challenge human civilization has ever had to face, because much of our entire civilization, most of the world's mega cities were built right at the coast, very close to sea level. So this is a little video, an animation of where the shoreline was 18,000 years ago during the last ice age. So the Farallones are out here. Here's the Golden Gate. I put in San Francisco, SFO, San Jose, and Sacramento. So what I'm going to do is just slowly raise sea level. So you can see it will expose the Farallones out here eventually. Comes into San Francisco Bay about maybe 9,000 years ago. And that sea level goes all the way up to Sacramento. In fact, Sacramento would have been underwater. And then sedimentation, particularly from the gold rush and rivers, came down and filled a lot of the bay. So our earliest measurements of sea level rise were again from tide gauges, which are water level recorded. We have one right at the Golden Gate, but that's a relative rate. So if we look at, say, New Orleans, the land is sinking. So the global rate of sea level rise is the same around the world, but if the land is sinking relative to New Orleans, it's going up really fast. If you go to Alaska, for example, Alaska was covered with ice during the ice ages that depressed the land for like sitting on your couch or your mattress. The ice is melted, but it's taken a long time for that to rebound. So now Alaska is rising, sea level is rising, but it's not rising as fast. So in Alaska, sea level is actually dropping relative to land. So those are relative or local numbers. In 1993, some really brilliant people figured out that we could measure sea level rise absolutely around the globe from space. So they launched Topex, Poseidon, and then there's been a series of subsequent satellites. So they are using lasers from space, making thousands of measurements over the ocean surface. But what we have to know is exactly where these satellites are relative to one another and relative to the Earth, down to 1/100th of a millimeter. How you do that is way beyond me, but then I don't know how a cell phone works either. It's like sending, a rocket to Mars and getting a little vehicle out and driving it around. So this is now the record of sea level rise from space over that last over 30 years. And what you can see is this rate. So this is in years, and this is the amount of sea level rise. It's accelerating. This curve is getting steeper. So its average is about 13 inches per century. But the last 10 years, it's now about 20 inches per century. And this curve is getting steeper because we're still pumping greenhouse gases into the atmosphere, and those are going to be there for a long time. So if we look around the planet today, there's 3 main sort of repositories of ice. One are all the continental glaciers. So this is the Alps and the Andes and the Himalayas. If we melted all that, it would raise sea level nearly 2 feet. Not so bad unless you live within 2 feet of sea level. There's Greenland. We melted all of Greenland, it would raise sea level 24 feet. That begins to affect probably 500 million people. Antarctica is the big problem. There's about 190 feet of sea level. So a total of 216 feet of potential sea level rise is contained in the ice. Nobody, no climate scientists think that's going to happen this year or next or this century or next, but it doesn't need to be 216 feet. 5 feet is going to create problems. 3 feet will create problems. So I'm going to show you, I hope the sound comes through on this. This is a film. It's part of a longer film called Chasing Ice. And these are a couple of graduate students who are up on the bedrock of Greenland, watching the front of this glacier. Then they're filming it and they're talking to their advisor someplace. They've been sitting there, they're kind of bored. And then things start to happen here. So let's see if this, can you hear the sound?
On the phone with Jim on one of our regular check-ins. Jim, just nothing's happening.
Yeah. It's going well. We had some serious bouts of wind, but other than that, things are fairly well set up here. We've got
It's starting out of, I think, Adam's starting.
oh wait, the big piece is starting to get.
Let me call you back on that. Okay, bye.
Still going?
Yeah, that D section right there. Holy shit, look at that big bird rolling. All four running, right? Yeah. Look at that.
See how, look at the whole thing.
So this is a concern with both Greenland and Antarctica when these big glaciers start to move into the ocean.
Our face is 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. Only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over, and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. We watched and recorded the largest witness calving event ever caught on tape.
So how big was this calving event that we just looked at?
This is
So it's
this
an
is Jim, the
illustration
professor.
in the sense of scale. It's as if the entire lower tip of Manhattan broke off, except that
The thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. It's horrible, very thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
So sort of a dramatic capturing of the kind of things that are of concern. So natural coastal environments, whether they're coral reefs or mangroves or seagrass, they've been adjusting to those 400 feet of sea level rise for millions of years, and they will continue to do so in the future. We spend a lot of time today worrying about protecting these habitats around San Francisco Bay, for example. I think they're going to do fine. But what isn't going to do fine is the cities in the world, particularly the coastal cities. And these just happen to be the two that are closest. Cities have never had to adjust to sea level rise because civilization really developed at a time when sea level was pretty stable. So something like 150 million people around the planet live within 3 feet of high tide. In the USA, maybe 13 million live within 6 feet of high tide. So there's two sorts of problems along the California coast, or two challenges. One of these low-lying shoreline areas. San Francisco Bay is one example. We've got Southern California places like Long Beach and Newport and Balboa, and some in Monterey Bay, Capitola, Rio del Mar. And then there's the higher, steeper cliffs and bluffs. So they are retreating due to wave attack and other things, but there are two different environments that present different problems. And that picture I opened with is Pacifica, which was being protected at that time. These buildings are now gone as the cliff is retreated. So San Francisco Bay, as an example, that's very low, it's surrounded by 20 wastewater treatment plants that serve, almost 6 million people. 600 million gallons of wastewater a day comes into those. For a bunch of reasons, they were built right at sea level. Water flows downhill, so we always put a wastewater treatment plant at the lowest spot in the community. Problem is, as sea level's rising, these pipes are no longer going to go, there's not going to be gravity flow into the ocean. The other thing that's maybe surprising, ocean water extends from the Golden Gate 100 miles inland to Sacramento. So that little video we showed of sea level rising going up to Sacramento, we have ocean-going ships that go all the way to Sacramento. So it's not just the shoreline, but it's low-lying areas all the way up the valley, all the way up the river to Sacramento. Airports, SFO, actually most of the big city airports on coasts around the country were built out on fill over the water or on swampy marginal land because there wasn't room in the middle of the city. So whether it's Boston, Washington, D.C., Miami, San Francisco, SFO was built on fill about 2 feet above high tide. In fact, it started out sort of as a muddy cow pasture. It was called Mills Field in the 20s. So if we look today, there's a website I use often that's put out by a group called Climate Central. And this is called basically, it's a way you can go to any place in the country. It's called Surging Seas. NOAA, the National Oceanic Atmospheric Administration, has a very similar site called the Sea Level Rise Viewer. And it uses the most precise land elevations. And then you can add sea level to it in 1 foot increments and see what's going to get hit. So this is SFO, and you can see Oakland over here. I just picked this, but you can take any place in the country and do this. So this is 0, basically high tide today. If we add 1 foot above high tide, that much of SFO goes underwater. The area inland from Oakland is less than that. The airfield itself is a little higher, but it was also built on fill. If we add 3 feet, which we could have easily by 2100, all of SFO is underwater, as well as Foster City and Redwood Shores. This is Highway 101. And if you go to 5 feet, which is reasonable by 2100, a lot more is underwater. So this is just sort of a way of finding out what's at stake. And again, you can do that anywhere. So sea level rise is one thing. That's a long-term, millimeters per year, feet per century, but there's also short-term events. And we had those this last winter where we had very high tides, very large waves arriving at exactly the same time, along with onshore winds. It also happened in the winter of 1983. A lot of coastal damage. And there, I'm sure you'll come to Capitola, typical summer picture in Capitola. And then extreme storm. The beach is gone, the water's coming in across the beach, over the seawall, into the city. And that happened again this winter. The Embarcadero has sort of become ground zero in San Francisco for high tide. And all you have to do is look behind here and see what is at stake back here. The airport, SFO, is now in the process of planning for a wall, an 8-mile long wall around the airport that they hope will protect them to about 2080 or so. I think the cost is about $550 million, and they're doing now the environmental work on that. What will be the impacts? This is Sausalito, and this is a parking lot, but this is high tide during a very high tide today. And this is a place you may know as you go over the Golden Gate and head north. This is the off-ramp that would go into, head out towards Stinson Beach and Mill Valley. This is not flooding. I mean, it's not fresh water, it's not rain, that's ocean water. So these are the things we're dealing with already. So what next? What are the options for the future? With global climate change and sea level, there's really 3 options: mitigation, adaptation, and suffering. We're already doing some of each, and the only question is what the future mix will be. The more mitigation, the more we can stop climate changing, the less adaptation and suffering will be required. So adaptation, we can all live on houseboats. It's not going to work. We can put a few people on houseboats, but we can't put, hundreds of millions of people living close to sea level. Mitigation we're doing slowly, and suffering, the fires we've had, the storms we've had. So as I said earlier, 77% of all of our energy is now provided by fossil fuels that are all producing greenhouse gases as we burn them for our power. So transitioning away from fossil fuels to renewable sources is really the most effective way, and maybe the only way, to mitigate the effects of climate change. It isn't going to be easy, but it's really our only realistic option. As I said, announcement just came out last week that, in fact, this is going back a couple of years, that for the first time, this is the amount of energy we produce from coal going down, and this is renewables going up. Still, most of our electricity is provided by natural gas, which we're burning more of. It's cleaner, it's still a fossil fuel. And then nuclear, which has stayed essentially the same for quite a few decades. And this is sort of where that renewable energy, the increases are coming from. A big part of ours is hydroelectric, but we're not going to build any more big dams in California, probably in the US. We've dammed all the easy sites. In fact, we're beginning to take dams down. So this hydroelectric isn't changing much. A little bit of geothermal in California. The ones that are increasing rapidly, these are wind turbines, and then solar is increasing. So they're coming along, but we still have a long way to go. So some of our options for dealing with sea level rise: there's denial or do nothing. There's putting more sand on beaches. There's armor, seawalls, and rock revetments. And then there's something that most coastal homeowners don't want to talk about, but in the long run, we're going to have to relocate away from the shoreline, whether we call that planned retreat or unplanned retreat. This is what's going to happen. So there's denial. Not very effective until something happens. And we have people writing books that sea level is not rising. Well, sea level is rising. We know that very, very well. There are no alternate facts when it comes to sea level rise. So the East Coast has spent probably about, well, we know pretty well, a little over $12 billion putting sand on beaches, about 1.5 billion cubic yards of sand. Think about that as about 150 million dump truck loads. You put it on the beach, it lasts for a winter or one storm and it's gone. It's sort of this continual process the Corps of Engineers is doing, mostly with federal dollars. It's very short-lived and very expensive. California, we haven't done much of this. Some down in San Diego County, they did 2 nourishment projects where they added about 3.5 million cubic yards of sand. They're dredging it up from offshore, putting it on the beach. It's cost about $46 million and it's gone in a year or two. The waves erode it, move it off coast and down coast. And now they're talking about a new one, another project for $36 million more dollars. I would say it's a very poor investment. Coastal homeowners love it, but we're paying for it. Historically, the main thing we've done around the US, particularly in California, is armor. We built seawalls of a number of different sorts. We built these rock revetments. And today, for Southern California, about 38% of the entire coastline is armored. This is down in Solana Beach. For the state as a whole, about 14% has been armored, but that takes into account places like the Big Sur Coast, a lot of the Northern California coast where there aren't so many people. Santa Cruz County, about 25% of the whole coast is armored. This is out at West Cliff, and this is down in Pajaro Dunes. But what's happened is the California Coastal Commission, which controls permits for things like this, is basically said, unless you had a house here when the Coastal Act was put into effect in January 1, 1977, we're no longer to give you a permit to build a seawall because of the impacts they have. There's been a recent court case in Half Moon Bay which is challenging that, but that's where we've been, and I will guess that there's not going to be many more seawalls built. In the long run, there is nothing we can do to hold back the Pacific Ocean. And we have enough greenhouse gas in the atmosphere, and we're still adding carbon dioxide. Sea level is probably going to rise for at least another couple of centuries. We can slow it if we do things soon, but there are other places, the East Coast, for example. This is the Cape Hatteras Light. Coast here was retreating at about 10 feet per year. They picked it up and moved it. Cost about $12 million. It was a national park, and it's the highest brick lighthouse. They managed to move it. This is a house out at Rodanthe, where a number of houses are now falling into the coast or into the beach. They actually, house movers can move things. I actually had a house moved once. A lot of buildings, that's going to be much more difficult to do. You may know the Sonoma coast. This is a place, Gleason Beach. Some people call it Malibu North, where they built an entire row of homes right next to Highway 1. They have their septic tanks down on the beach behind these seawalls, but this is a very unstable stretch of coast. And it now looks like this. Well, a couple of years ago, most of those houses have collapsed. The few that are left are being taken down. So this is what I call unmanaged retreat. And if you look, Highway 1 is within a few feet of the edge. So Caltrans got together with the California Coastal Commission. They planned a relocation. They took down those houses and they're building a bypass. Most expensive thing was this bridge, but this cost $62.5 million. And they just opened it. So this is an example of managed retreat, but it's a bit different for public infrastructure versus a private home. Capitola, apartments on the clifftop, undermined during Loma Prieta earthquake. Those have been taken down. Some of you may have children that have gone to UC Santa Barbara, where I was a student. These apartments have been built right on the cliff edge. It's eroding very quickly. Well, quickly, a foot per year. And what you can see if you look at this one and now the next photograph is parts of those were taken down. These decks are all gone. So there are places where we're actually moving back. And then we look at parts of Southern California, Huntington Beach. These homes were all built virtually on the sand at sea level. Balboa Island, Newport Beach, virtually at sea level. The island has $4 billion of assessed value in their homes. And water is already lapping over that wall into Balboa. This is that same site, surging seas. So here's Balboa Island in Newport. This is at current coast, current sea level. If we add 1 foot above high tide, it starts to go into the streets of Balboa Island. If we add 3 feet, all of the island is underwater and the coastline as well. So we have some problems. You may know Malibu. This is Broad Beach. That was actually, these homes were built out on the sand when the beach was wider. It's now becoming not very much beach at all. You got to figure out what to do because the Coastal Commission said this was a temporary structure. There's a person you may know that lives here, James Bond, and I did some work down here. And in the introduction, she said I was honored as a California's coastal heroes, and so was Pierce Brosnan. So we got to spend a little time together. Had an event at the aquarium of the bay. The only difference is he dyes his hair and I don't. And he's such a handsome guy. So some of these big cities are going to be problematic. If you've been reading, Miami Beach is a major problem. And these cities were built without any regard to sea level rise. We didn't think about it. They're still being built. And you can see this beach is very narrow. What's happening to these sandy barrier islands along the Atlantic coast is they are naturally, with sea level rise, they would migrate landward. But we're still building Miami. Between Miami and West Palm Beach, there's 50,000 condominium units being constructed. And you can buy one of these, you know, for $1 million or $2 million, but they're right on the sand. And you remember a couple of years ago, this one collapsed. Seawater is coming in under these. I think in that case, it had to do with corroding some of the reinforcing rods. So they say the state bird of Florida is the tower crane. So this is going to be a major dilemma. Here they are trying to pump the Atlantic Ocean out of Miami. Most of the rock is limestone. So even if they build a wall, the water will seep under that up into Miami Beach. So there's a tough road ahead for them. A lot of pictures of Miami, and this gets routine, high tide, sunny day flooding. It wasn't a hurricane, it's just high tide. And the Embarcadero, similar, not quite as bad yet. What is beginning to happen is economics is starting to weigh in here. And the insurance companies are realizing that these are bad investments. So what's beginning to happen, if you can't get insurance, you can't get a mortgage. So if insurance get out of insuring these coastal properties, they're starting to lose value. Unfortunately, the federal flood insurance program has been insuring and reinsuring, and we've been subsidizing this for decades. And every time there's an effort to try to get these homeowners to pay the actual rate, it's turned down in Congress because of pressure from the congressional people in these states. So we've not made much progress. We're still subsidizing people building and rebuilding in these locations. So I'm going to sum this up with 5 two-word sentences. It's real, it's bad, it's us, scientists agree, there's hope for California. Was mentioned the study that Governor Brown requested. I was asked to chair this, and this was looking in 2017 at what we could expect for future sea level rise. There's now a 5-year update, a sea level rise task force that I'm on, and we're working on that report. But there's a lot of different projections. We're sort of here now. This is the historic rate, and you can see it could go a lot of different directions. These different curves are relative to greenhouse gas emissions. So if we cut back everything now, we might be able to keep this below 3 or 4 or 5 feet by 2100, but it could be 8 or 10 feet. So these future projections are based on our greenhouse gas emissions. So this is this last winter, about a block, 2 blocks from where I live, where we had these huge waves at high tide hitting the coast, tearing out parts of the road and bike path way before anybody expected that to happen. The road is now down to 1 lane, and the city's trying to decide how are we going to adapt to this. So burning fossil fuels, climate change, and sea level rise are intimately connected. This is a little bit political, but just over half the Republicans in the Senate and the House who took the oath of office in 2023 expressed views in opposition to what the overwhelming majority of climate scientists report is happening with Earth's climate. In the House, there are 110 of them, 5 from California, including the Speaker, and 19 were newly elected. In the Senate, there are 39, 4 recently elected. In one of his early speeches, McCarthy, as the new Senate Majority Leader, called for, among other things, I should say this is not the Senate, he's the House Majority Leader, enhanced use of fossil fuels. A couple of statements or quotes, people you may remember, Daniel Patrick Moynihan, who was a 4-term senator from New York and served in a number of Republican, Democratic administrations. Everyone's entitled to their own opinions, but not their own facts. And Neil deGrasse Tyson, who's an astrophysicist and science communicator, says, a wonderful thing about science is that it's true whether or not you believe it. And I just leave you with this. Meanwhile, sea level continues to rise. Okay, I'm going to leave you with that, and I thank you for your attention.
That was great. Thank you.
Well, that might have been a lot to dump on you all at once, but I figure you are well-informed, intelligent people. You could handle it.
Thank you. It was great.
It was.
Connecting all the dots.
I loved seeing that calving incident. I'd watched it several times before. What's the movie Chasing Ice?
Chasing Ice, yeah. It's pretty dramatic, and every time I've shown that, people are just kind of shocked that in fact that's what's happening.
Incredible.
So happy to answer questions, or maybe you're getting late for you.
No, but I had one. Have you guys talked at all about the common law public trust doctrine?
I'm not a lawyer. I work with the Coastal Commission, and I work with property owners. I'm not an advocate as much as I just try to put the science out there. And I'm not sure how you're referring to it, but that's one of those legal issues that's going to make things difficult, I think, messy.
Or it could make things a lot easier.
Easier, yeah.
And we've always had it in California. It's never been repealed, and the legal profession has been actively trying to deny it. And you know, what have you talked to anybody at the Coastal Commission who, you know, what they were doing with the Public Utilities Commission and the desal plants was just horrendous. And I think they're going to have to figure out whether, you know, the rule of law applies in California or not.
Yeah. Well, I think one of the challenges is there's a lot of lawyers out there who will go to work for a property owner and push a case. And so certainly, you know, the laws you talk about are this, you know, kind of property ownership in the coast is a lot of those seawalls and revetments were built on public beaches.
Absolutely.
And we have a organization or an agency in California called the State Lands Commission that leased a lot of that land for nothing just because they didn't want to worry about it. And that's becoming maybe another way in which we can exert some pressure. But what happened in Half Moon Bay, or apparently is underway, a group of homeowners that had property right on the coast that's eroding fairly rapidly south of the harbor, has sued the Coastal Commission because the Coastal Commission says, no, we're not going to give you more permits for more seawalls. You've got to figure out something else. You can move back, you can relocate your house. And it's based on the language in the original Coastal Act that said, you can apply for a permit to protect an existing structure if you mitigate all the impacts. And what's happened in the years since 1977 is existing structure, presumably if it was written in 1977, meant existing in 1977. But people have said, no, I built my house in 2020, it's existing, I want a seawall permit. So that's what this lawyers took it to a judge in a superior court, and he reinterpreted and said, no, it's existing now. The Coastal Commission has been misinterpreting their own document. So that's sort of
Well, the Texas court did a ruling on mifeprestone, and it's going to be interesting to see how that goes. In 1987, Howard Hughes didn't want the public trust to apply to his land, and Warren Christopher and Zoe Baird put up the argument, and what was it? It was Rehnquist who wrote the most racist opinion known, and said that if anything as onerous as the public trust would be applied to someone's land, there has to be notice. And he did that case in '87, but the Sun Microsystems guy on Martin's Beach tried the same thing, and he lost. And
there's a lot going on out there. I was going to see somebody had a question for what's the recommendations of the most impactful actions for an individual to take at this time. And I get asked that a lot when I give talks. And I'll say there's one thing everybody can do that has a huge impact and it doesn't cost anything. Are you listening? Vote. And we see the effects of who we vote for, but I mean, there's also personal choices. There's a couple of interesting sites where you can actually look at your environmental footprint, and it shows, how you live, how much energy you use, how you travel, what you eat, what you buy. And it's interesting that if everybody on the planet, all 8 billion people, lived with the consumption style of the average American, it would take 5 planet Earths to provide it, which we obviously don't have. And you can see some of the countries like India are, less than 1 because they don't consume very much. We are the big consumers. So our consumption, so we can, make all those simple choices in our home, our, solar panels and so forth. And you can join, like you are, part of an organization that has maybe a larger clout than you as an individual. And then, as I say, vote, because that's ultimately what's going to determine our future and what we're unfortunately suffering from now. What does there's hope mean in the context of sea level rise?
I agree with you about voting. We're the league.
Yeah. I guess once we understand it, then we can begin to do something about it. There's a couple of great proverbs here. One is something from South Africa is, if you don't think little things can make a difference, you haven't spent a night with a mosquito in your room. And the other one was from Margaret Mead, as a well-known anthropologist, says, never doubt that a small group of committed citizens can change the world. In fact, it's the only thing that ever has. So, and the other one was by Nelson Mandela. Education is the most powerful tool we have for changing the earth and the world. But right now, that education, I think, is in trouble for a bunch of reasons. We have a lot of people who, without getting any deeper into politics, that have alternate facts, that believe different things, lobbies and so forth. So some things have been really hard to change. But, as a father and a grandfather and a teacher, I feel I have to have hope for the future. And we can see positive signs. Again, for the first year, renewables produce more electricity than coal. It's an incremental change. I call it aggressive incrementalism. Keep making these little steps forward. Or another word I use is sober optimism. Let's be optimistic, but let's be honest with it. Bay Area wastewater treatment. I'm wondering what might ultimately possible as alternative to the present system. Are the groups working on this? We actually just are being funded for a project on the margins of San Francisco Bay, somewhat related, but it's all of the toxic solid waste sites where stuff has been buried around the bay, and there are hundreds of these, and how they're going to change with sea level rise and a rise in the groundwater table, and how this affects socially disadvantaged low-income groups, which is where a lot of those impacts are going to be. I don't know anybody that's working with the wastewater treatment issues. I mean, we have places where people have built on the beach and their wastewater runs downhill into a tank and then it's pumped up to another system, but that's expensive. So around San Francisco Bay, I don't know of any groups working on this. I would hope those individual, wastewater management districts are beginning to think about it, because as sea level rises, water's not going to flow by gravity out into the ocean any longer. So sorry to leave you with such bad news, but you let me pick my topic.
At some point, it'll become vogue to have an underwater apartment.
Well, I think that's what's going to have to happen in Miami Beach, or else we're going to fill in the ground floors and people are going to live on top. But it's like seeing Miami or the Embarcadero, and it's.
Yeah.
I think people can begin to accept what's happening and the cause of, but they can't accept what we're going to be able to do about it.
Crazy too, because the complete Keys are going to be underwater, and the whole southern part of Florida.
Most of Florida is very, very low. The highest elevation is about 340 feet.
Yeah.
But most of it is where sea level 10 feet. A lot of Florida goes underwater. So, and we never had to worry about it, but we're still building in those places. How do your students take this?
It's crazy.
Well, I'm giving them assignment this week to go do this environmental footprint to see what their individual impacts are, how many planets it would take to support the world population if they all live like they did. And I think, at least at Santa Cruz, probably Berkeley, students are generally pretty liberal, pretty progressive. And I think they believe they are pretty environmentally conscious. Yet when I did this last year, people had no idea. Something like flying down to see their girlfriend in Los Angeles every weekend. Airplanes use huge amounts of fuel. Another student shocked me, lives on campus, and he said, maybe I shouldn't be calling Uber Eats to bring meals up to campus in a car 3 times a day. And I went, are you kidding me? So this is sort of a wake up for them, but then how much does that translate to their lifestyle and their sort of consumption habits when they get out of school? So I'm working on it. I'm not going to retire till the world's saved.
That was a great presentation. Thank you.
Thanks very much.
So there's also a group, we had people come to present to us from a group of people who are trying to keep Richmond from building more housing on the north side of the bridge that goes across between Richmond and Marin.
There's also Hunter's Point, that big ex-military base that's got. Yeah, the bay was pretty much treated as a waste discharge site, both the water and the margins of it. And now it's sort of coming back to haunt us because the groundwater table's rising and sea level's rising and all that fluid is. So we're going to try to spend the next couple of years trying to at least pinpoint where the major sites are, which are the most vulnerable, which populations are at risk.
Right. Well, it seemed like in this case, they wanted to build more condos and they wanted to have ferries going across to San Francisco and all kinds of fancy stuff. And it didn't seem like the space had it didn't have the ability to hold all of it. And it was mostly a group of people who were trying to infiltrate the government of Richmond to try and get this passed. But as far as I know, they haven't survived. They haven't managed.
They haven't done it yet.
Well, there's the other plan underway. Is it Treasure Island?
Yes.
That was mostly fill and a little bit of rock, and now there's a major development plan there, but that is very close to sea level. But as long as there's money to be made, and we're still needing to provide housing for people, these are the kind of things. But there's a lot of safe places to build. You don't have to build at sea level on the water. Those are just the most desirable places we've discovered. But we know that now. What are the UC Santa Cruz faculty doing on this? Well, I talked to a couple students today. There's a sustainability office, and they're trying to do what they can. Actually, UCY, there's a whole sustainability program. So in terms of energy use, organic waste, transportation, there are people in some of the departments working on this.
UC Berkeley has some places that it has set up systems for, whether it's for earthquake testing or whether it's for holding.
Right. That's a whole different issue.
Holding their books in large container things so that they can ship them out to whoever in the system orders it, all that kind of stuff. But it's right along the edge of a slough. And they could move all that stuff. It's not that big a deal, but it's something that it's like, okay, where would they move it?
Right. That's like if SFO goes underwater, if they don't build the seawall around it, where would you move San Francisco International Airport to? And you got to go a long ways to find a flat area that's that big. So that's just one problem, that the airport is a giant economic revenue source and employs a lot of people as this huge hub. But so is Washington National, Boston, Logan, Miami. In New Orleans, New Orleans is below sea level. The airport's below sea level, and they're dependent on levees, which broke in Hurricane Katrina. So that's why I said I think this is the biggest challenge human civilization will ever have to face. COVID's going to go away. Trump's going to go away. I'm going to call that a problem. But sea level's not going to go away, and the climate's not going to go away. Are you hearing much about living shorelines, living seawall options? Yeah, and we have a sort of a center now that's looking at that. And so we think of living shorelines, we think of things like mangroves. There's trees that can grow in salt water, trap sediment, kind of stabilize the shoreline. We have coral reefs that can diminish energy. Those are in tropical environments. We don't have either of those on the California coast. Around the bay, we have marshes and so forth that we spend a lot of time trying to protect. But those are Band-Aids, because when sea level rises 5 more feet or 2 more feet, it's going to right up against the development. Those marshes will be flooded. But if you look at the outer coast of California, it's a really high energy coast. There's nothing you can plant there that's going to make a difference. You can't plant coral. You can't plant mangroves. Seaweed doesn't really matter. So living shorelines can work in low energy environments for a while. But I think it's a sort of a panacea that everybody wants to grab onto, so we won't have to build any more walls. But I think there's limitations to where that's going to be successful and how much sea level those can handle, how much sea level rise. Good questions.
I have a question about it. Since the airport already is built on fill, couldn't you just build it higher? I mean, because it is going to be very hard. And we'll have to go a long way to find a piece of land that will.
You could.
Airport.
And I'm going to take a quote, but this is not to diminish your question, because it's a really good question. There was a well-known coastal engineer at Berkeley for many years, Bob Weigel. He died a couple of years ago. He was 92, became a colleague and a friend. And whenever I'd come up with this solution to a problem that I thought was brilliant as a young person, he'd say, Gary, for every complicated problem, there's always a simple answer, and it's always wrong. So we could raise San Francisco Airport, theoretically. So you've got all those buildings and all the terminals. So how you do that? People said, well, let's raise Balboa Island. how do you do that? Do you lift one building up at a time? Do you elevate one one of the landing strips at a time? It's sort of hard to imagine, but the seawall, we can do those, $550 million. But it wouldn't be done now till about
When we build it.
2034. So it's a long time to do a project like that. And we've
No.
moved Highway 1 inland in Sonoma County. We've moved it in down at San Simeon, but each of those projects was tens of millions of dollars, and those were easy. Just move the road in. So
But
when
you also worry about earthquakes where the yes, where the
yeah.
airport.
Well, you know what happened in Oakland during the Loma Prieta earthquake with the cypress structure that collapsed. And fill, depending on how it was engineered, is very susceptible to seismic shaking. Yeah, that's not a climate issue, but it's another issue.
Nicole.
There's just no end of things out there that can get you. I just finished a book that's now in review. It's called California Catastrophes, the Natural Disaster History of the Golden State. So I look at all the history of flooding and earthquakes and volcanoes and coastal storms. And it's amazing how when you go back and look at the old newspapers, how often the same things happen in the same places, but we have what I would call a short disaster memory. We forget about it. Let's rebuild these fires. Might have my building permit so I can build back in this same area. Let's rebuild cities instead of thinking about a safer place. We're getting better at engineering, but the tower in San Francisco that's leaning, why did that happen? Well, foundation was different than they thought. I don't know if they've solved that yet, but
No.
that's it's like that condo in Florida that collapsed, almost instantly, that nobody was ready for. So, but there's plenty of safe places to live. I'm sure you all live in really safe places. Although I will say the East Bay is overdue for a big earthquake. The last one was 1868. There's been these handful of little ones recently down in Hollister, and I think in the East Bay.
Yeah,
But fortunately, they don't occur as often as tornadoes do. And again, in the Loma Prieta earthquake, there was 66 deaths. A handful of those were in Santa Cruz, where the earthquake was centered. Most were in Oakland when that Cypress freeway structure collapsed. Nobody died in that entire earthquake in a single family wood frame dwelling. So generally, we live in pretty safe structures in this country versus what just happened in Turkey and Syria, where it's unreinforced masonry or not enough rebar. And that number now is, I think, almost 58,000 people died. So that's a different beast. You guys have been very patient. I hope this was useful.
Very useful. I have a question. Maybe it was about 15 years ago. There was a lot of talk about peak oil. And you mentioned today the problem isn't with fossil fuels, it's with what we do with the,
Right.
what is the situation in terms of fossil fuel, and the whole notion of peak oil just evaporated from discussion?
Yeah, what happened was those original peak oil estimates were based on sort of what we understood then as reserves, what was probably down there. And three things happened. One, we started going into the Arctic, which wasn't contemplated, and there's still problems there, and we haven't done that much. The second was we started drilling deeper. So the deeper you go, the more expensive, and the pump it out. But when gas gets to $5 a gallon, you can afford to drill deeper. And the other was we've been fracking. So we actually now go into these tight formations and inject sand and some solvents that have their own set of problems so we can extract oil that we didn't. So, and you can go online and say, what's peak oil now? Well, maybe it's 2040 or 2050. There's a lot more coal out there, but coal is really this fuel that's starting to go downhill because of the cost and the impacts, and it's just not economic anymore. despite the fact that most of it is in Kentucky where Mitch McConnell is. Let's see, Jeff Goodell. Yeah, he wrote The Water Will Come, I guess. Great book. During the mid-Pliocene, about 4 million years ago, when CO2 levels were about the same as they are now, the global sea level was about 70 feet higher than it is today. So there's been some comparisons made. That sounds a little high, but if he says it, he said it. He's not a scientist, but he's a great journalist. There's a lag with greenhouse gases and how quickly the planet responds. So what that tells us is it could be a lot worse than what we're suffering from right now, and we're still adding to CO2. So that's, I just saw a number yesterday that said there are 635 million people living within 30 feet of present day sea level. So this is 75 feet. I would guess there's probably 2 billion people. And again, if you look around the planet at the mega cities, over 10 million people, you know, it's Hong Kong and Guangzhou and Shanghai and Jakarta and Dhaka and Karachi. Most of those big cities are within a few feet of sea level, and they have millions of people that are going to be difficult to move. So the scenario for the future, I really wish I was going to be here in 2100. I don't think that's going to happen. Just to see how fast this progresses. But that movie Chasing Ice just gives you one sense of what could be happening in Antarctica. And there, the glaciers, like they were photographing, these massive glaciers are being sort of held in by these floating ice shelves, sort of like a cork in a champagne bottle. And what's happening is the water in Antarctica is getting warmer, and it's starting to melt the underside of those ice shelves. And the atmosphere is getting warmer, it's melting the surface of them. So the question that a lot of scientists are trying to figure out through climate models is, when are the corks going to come out? And then the scenario that movie photographed in Greenland is going to be very real. So stability-wise, some big chunks have broken off of these floating shelves. A couple of years ago, one the size of Delaware. But when it's floating, it's like an ice cube in your glass. That melting doesn't raise sea level. People have a hard time with that. But if you take a glass and put, 10 ice cubes in it and fill it up with your favorite drink, and you watch as the ice cubes melt, the level of the water won't rise. It has to do with the density of ice is less than the density of water, which is why icebergs float. So hard for me to know exactly. I don't work in Antarctica, but I think a lot of these are sort of questionably stable. But as long as the climate keeps warming and the water in the air keeps warming, we're sort of tilting towards those coming loose. Well, here somebody added, on the scale of decades, you can only deal with so many disasters at once, right? But to think that we have a Congress and a Senate and a lot of states that are doing, funded by oil company lobbies, and recent work has come out that shows the oil companies knew about climate change in the 80s.
Sure.
They were making models, climate models, mathematical models. They're as good as anything the scientists are making today. And they said, this is bad. This is going to be catastrophic. And the oil companies basically buried it. So you can say, well, the oil companies, the goal of a corporation is to make money for its investors. But, is there any conscience here about the future? And do those people have children or grandchildren? And how are they going to live with this? So anyway, I think we're supposed to end at nine. So
can I just ask, can you tell us about whether carbon capture is realistic as a solution?
So I said pretty strongly that I think getting greenhouse gas under control and stopping fossil fuel was the only realistic. So it reminds me a little of my friend at Berkeley who said, for every complicated problem, there's a simple answer and it's always wrong. There's been what we call geoengineering. So people have said, let's shoot all these little mirrors up there and we're going to reflect sunlight. Well, when you look up at the atmosphere, you know, is it 20 miles thick or 30 miles thick, and realize the volume of the atmosphere. How many little mirrors to cover that? Can we take carbon dioxide out of the atmosphere, and then where do we put it? So vegetation is good, but we're burning vegetation up. And it takes a lot of that. People talk about, well, seagrass and kelp, but if you look at the amount of carbon dioxide and the amount of kelp and seagrass, I mean, it's not a bad idea. I don't think it's going to be on the scale. Some people are proposing putting carbon dioxide deep in the earth in rocks. But it's one thing to take it out of the flue gases of present power plants. And there's a person that graduated from Santa Cruz who's actually figured out how to put that carbon dioxide into concrete and sequester it. But there's still a lot of energy involved. So keeping the scale of things, it's nice to keep thinking about these. It's like, can you imagine everybody on the planet sticking a vacuum cleaner hose up into the air and trying to suck carbon dioxide out? It's only, 420 parts per million. It's not. So my own sense of, we should be thinking about these things, but I think there's a lot of people that maybe make money out of a little device. Somebody in Sweden or something, or Denmark built something that can, do 2 cubic yards a day. Well, we've got billions of gigatons. So I still feel until we cut the carbon dioxide emissions back, which we've got a long way to go, there's not really any hope of getting to those levels we should be getting to.
There's also problems with the methane. It's underneath the water, and there's lots of it in upper Russia.
Yeah, and methane is actually quite a bit more potent than carbon dioxide. We don't have quite as much of it, but it's being released from oil wells. Yeah. A funny way, cows burping is actually true, and other sources. So anyway, I think I probably depressed you enough, but I think, again, the more education we have, the better. So thank you for the opportunity to speak with you. Stay in touch with me. Actually, my emails on the internet is just my last name, Griggs at ucsc.edu. So you feel free to contact me and I'll keep you in touch.
Thank you so much.
Okay.
Great discussion, and glad that you have hope for the future.
Thank you. Good to see you all.
Bravo.
Thank you.